Hello students, this is Sudeep Yadav from Spectrum Chemistry. And students, if you are first time visiting to my channel, so please like and subscribe my channel and press the bell icon to get the best explanation of NCERT book class 10th subject science. And in science I will discuss with you chemistry. And students, if you are watching this video, so please go to my playlist and watch the previous 5 videos of this chapter to create a better understanding for this chapter. And in this chapter I am going to discuss with you salts and the classification of the salts. So let's start, students. The first topic which we are going to discuss, that is more about salts. Salt is an ionic compound that contains a cation, that is a base, and an anion, that is a acid. It is present in large quantities in seawater, where it is the main mineral constituent. Salt is essential for animal life, and saltiness is one of the basic human tests. Salt is an ionic compound that has a cation other than H positive and an anion other than OH negative, and is obtained along with water in the neutralization reaction between acid and base. So this is the brief introduction of the salts. Okay, now next example, let's see example. There are the two examples, that is the sodium chloride and copper chloride. Okay, and how we can form the salt? So when you will be react and when you will be treat a acid with a base, then as a byproduct you will be get salt and the water. So by the help of the acid base reaction you can get salt and the water will form. Sodium chloride is one of the best known salt which we are using in our daily life. One salt is known to almost everyone because of its widespread use in every day, which I have already taught you. Okay. Now next, properties of salt. This is very important. So let's see what will be the properties of the salt. The compounds sodium chloride has a very different properties from the element sodium and chlorine. So let's see what are the properties of the sodium chloride. Salt water contains ions and is a fairly good conductor of electricity. Means when you use a salt solution, so when you will pass the electric current from this solution, so the current can be passed because due to the presence of the ions inside the solution. So means salt, when you will be dissolve the salt inside the water, it will dissociate into the respective ions, and these ions are the responsible to show the conductance of the electricity in the solution of the salt. The electrostatic force of attraction means the force of attraction by which the ions are holds to each other. Okay, so this electrostatic force of attraction holds the ions together, and a chemical bond is said to be termed and said to form between them, that is known as the electrostatic force of attraction. Okay, and this is the charge bodies attraction, you can say. Okay, means both having the charges and both having the attraction force, and this attraction force is known as the electrostatic force of attraction. Now next topic, students, that is hydrolysis of a salt. So what will be happen when you will be do the hydrolysis of the salt? Let's see. Hydrolysis of salt refers to the reaction of salt with water. It is reverse of a neutralization reaction. In this reaction, when salt undergoes reaction with water, the constituent acid and bases are formed as products in hydrolysis. The salt dissociation to form ions completely or partially depending upon the solubility product of the salt, means which solution you are having. Okay, it depends on that, means the solubility, how much it is soluble inside the solvent. Okay, that is the solubility product of the salt. Okay, means on dissolving which kind of the product will form, this depend on the salt. Okay, is it clear? Now next, activity number 2.13. so let's start, students. What is activity number 2.13? what we have to do in this activity? Let's see. Number first, procedure. Activity 2.13 asks us to write the formula of various salts, their source, and group them into their families. So let's see what will be the answer. Our first formula: potassium sulfate, sodium sulfate, calcium sulfate, magnesium sulfate, copper sulfate, sodium chloride, sodium nitrate, sodium carbonate, ammonium chloride. So these all are the salts and their formulas. Next, acids and bases which forms these salts. So which acid we have in need to form the given salt, it's depend on the formula of the salt. How it will determine which will be acid and which will be base to form this salt? Let's see. When acid and base mix, they react vigorously and form respective salt. Okay, so means respective salt, like the calcium sulfate. If you want to be the form the calcium sulfate, so you're having the need of the calcium hydroxide or either calcium oxide. From both of them you can form the calcium sulfate. When you will be treat, suppose you have to form the calcium sulfate, so you can use calcium oxide. When react with dilute sulfuric acid, it will convert calcium sulfate and water will evolve. From where this is the water and this will combine to this and it will convert into the salt. So from this equation we can say that the salt, how the salt will form, which salt you have to form, you have to be see that which base and which acid you are having the need. Means if you are having the need to form the sulfate, a sulfate salt, so you are having the need of the sulfuric acid. Is it clear? And if you are having the need of the to form a calcium salt, so you are having the need of the calcium oxide or the calcium hydroxide. Okay, one more example I would like to discuss with you, that is the, suppose you have to form the potassium sulfate, so which acid and which base we will be used. So from the potassium sulfate you can predict that there is a acid will be the sulfuric acid. There will be acid, that is the sulfuric acid. And if we talk about the potassium, so the base from which we can get the potassium, there is a two bases, potassium hydroxide and potassium oxide. So let's see, suppose we have taken the potassium oxide, so here the water will evolve and it will convert into potassium sulfate and water. So there is a formation of the potassium sulfate. So now you can easily identify which acid we are having the need to form the given salt. Suppose you have to form the sodium nitrate, so which salt or which suppose you have to form the sodium nitrate salt, so which acid you will be use? So there will be there you can use the nitric acid, because HNO3 means there is a HNO3, that is the nitric acid. Or from when you will be dissolve HNO3 inside the water, at the time H positive and NO3 negative will form. Okay, so by the help of this you can identify which acid and which base you will be used to form the given salt which you have to be formed, like the sodium nitrate, so carbonic acid and sodium oxide or the sodium hydroxide you can use. Similarly, ammonium chloride, if you have to form the ammonium chloride, so you can use ammonium hydroxide as a base and HCl as the acid. So from the chemical formula of the salts you can predict which acid and which base you are having need to form the given salt. Okay students, now next acid used. Let's see. Sulfuric acid, you can use the sulfuric acid if you have to form the any sulfate salt like the calcium sulfate, potassium sulfate, sodium sulfate. Okay, hydrochloric acid, suppose you have to form the chloride salts like the copper chloride, calcium chloride, magnesium chloride. Okay, so you can use the HCl. Nitric acid, if you have to form the magnesium nitrate, calcium nitrate, potassium nitrate, so you can use the nitric acid. Similarly, carbonic acid, so if you want to form the calcium carbonate, potassium carbonate, sodium carbonate, so you can use the carbonic acid. Now next, bases used. Which base you are having the need? So as I have already explained to you that if you want to be form the salt, so you have to be identified the which will be the respective base. So sodium hydroxide you can use if you have to form the sodium carbonate, sodium sulfate, sodium chloride. Okay, so you can use the sodium hydroxide. Magnesium hydroxide, if you want to form the magnesium sulfate, at that time you can use the magnesium hydroxide. If you want to form the magnesium nitrate, so at that time you can use the magnesium hydroxide. If you want to form the magnesium carbonate, at that time you can use the magnesium hydroxide. Similarly, calcium hydroxide, if you want to form the calcium carbonate, you can use the calcium hydroxide. If you want to form the calcium sulfate, at that time you can use the calcium hydroxide. Calcium chloride, if you want to form, at that time you can use calcium hydroxide. Okay, so from the reaction of the given base with the respective acid, you can form the respective salts. Now let's discuss on the family. So for the family, you can say there are the number of the families formed, and family can be family can be on the basis of the metal as well as on the basis of the group like the sulfate, carbonate. Okay, so on the basis of these you can classify the salts also. Okay, so let's see. First of all, like this, suppose you have to classify the salts on the basis of the sodium salts. Okay, so whatever the salts you have, okay, in which there is sodium is the part of that salt, at the time you can say this salt is belonging from the sodium family, like sodium chloride, sodium nitrate, sodium sulfate, sodium carbonate, sodium acetate, okay, sodium oxalate. So these all are the salts of the sodium which are belonging from the sodium family. Similarly, potassium salts, potassium chloride, potassium nitrate, potassium sulfate, potassium bromide, potassium carbonate, potassium acetate. Is it clear? So these all are the salts. Similarly, ammonium salts means ammonium family salts, ammonium chloride, ammonium chloride and the ammonium sulfate, ammonium bromide. Okay, so these all are the salts of the ammonia. So by the help of this we can classify the salts and we can classify the family of these salts. Okay, I hope it will be understood. Okay, now next, pH of salts. Activity number 2.14 through the activity number 2.1 through 14 we will explain the pH of salts. So let's see procedure. The activity 2.14 asks us to collect some sample of various salt, check for its solubility in water and pH of the solution formed. So first which we have to discuss, that is the solubility. What is the solubility? All sorts of the inorganic acids and inorganic base, for example HCl, sodium hydroxide, etc. are readily soluble in water. Why? Let's see. Salts of organic acid and organic bases are mostly insoluble in water, but some may be soluble. Here only one organic salt, sodium acetate, is asked, which is highly soluble in water. Okay, so let's see what is the solubility. Here we have discussed about the solubility, and here we are going to discuss explanation of the solubility, why it's happening. Okay, so let's see. Salts of organic inorganic acids are polar in nature. So polar substances can dissolve inside the polar solvent. So let's see. Polar substances dissolve in the polar solvents like the water. Water is a polar solvent. Okay. Salt of organic acid and bases are mainly non-polar in nature. They dissolve in a non-polar solution. Means non-polar salts will dissolve inside the non-polar solutions, and polar salts will be dissolved into the polar salts. Okay, and inorganic acids are the polar in nature. So polar nature means they can dissolve in the polar solvent. Okay, and if there is a non-polar solvent, non-polar acid, okay, or non-polar salt होगा, at that time it can dissolve inside the non-polar solvent. Is it clear? Okay, the pH of the solution. Salts of strong acid and strong bases form a neutral solution with water. Example sodium chloride. Okay, so here you can see sodium chloride. Sodium hydroxide, when react with HCl, at the time it will convert into the sodium chloride. Salts of strong base. This is very important statement. Okay, salts of strong base and weak acid form basic solution. Means there is a suppose strong base. Okay, suppose there is a strong base. Strong base means potassium, sodium hydroxide, and it's reacting with the weak acid. So what will be the weak acid? Acetic acid. Okay, so when both will interact to each other, so at that time what will be product? This will be product. Okay, so this is the which kind of the salt? This is the basic salt. Why? Because we have taken a strong base and there is a weak acid. So when a weak acid will interact with strong base, at that time the salt which will be formed, this will be a basic salt. Is it clear? So example sodium acetate, which I have written. Okay, sodium acetate is a salt of the strong base, sodium hydroxide, and weak acid, that is the acetic acid. So it will form sodium acetate, that will be a basic salt. Okay, so it will turn the pH paper into red or yellow. Okay, now next, salts of a weak base and strong acid. A weak base and strong acid solution with water. Example ammonium chloride. Ammonium hydroxide is a weak base. So let's see what will be the reaction. So suppose here is a ammonium hydroxide when react with HCl. Okay, so what will form? Ammonium chloride and H2O. So this will be a acidic salt, because here is the strong acid and here is the weak base. So when a weak base will interact with strong acid, at that time the salt, whatever the salt will form, this salt will be the acidic salt. Means here acid is a strong, means it will be dominate. Okay, if here is a strong base and weak acid, at that time base will be dominate because it will be strong. Okay, so it's salt from acidic solution with water. Okay, explanation. Let's see what will the explanation. The pH of the solution depends on the presence of the hydrogen and hydroxide ion. Okay, H positive ion or the hydroxide ion in pure water. They remain at the equilibrium with 10 to the power 7 each. Okay, like that is the 7 pH. Okay, when we add salt of a strong acid and strong base, it dissociates into its ion fully and equilibrium remains the same. Means suppose here is the sodium chloride and you have dissolved it inside the water, and it will be there is no disturbance in the equilibrium. Okay, so means equilibrium will remains as it is. Okay, but a salt of the strong acid and a weak base, or a salt of a weak acid and a strong base, does not dissociate fully and disturb the equilibrium of water. Okay, at that time they will disturb the equilibrium of water. So this is the reason behind it. The acidity of the salt and the basicity of the salt and the acid, and you can identify the which will be the acidic salt and which will be the basic salt from the litmus paper. Okay, sorry, PS paper. Okay, so this is the explanation. Now next, classification of salts. What is the classification of salts? Let's see. Based on the nature, the salts have been classified into different types. They are normal salts, acidic salts, basic salts, double salts. So here we are having the 4 kinds of the salts. So let's see. Number first, normal salts. These salts are formed by the complete replacement of the hydrogen in acids by other metal cations from the base. For the example, sodium chloride is formed salt formed by the reaction of HCl with the sodium hydroxide. So this is the example of the normal salt. Now second, acidic salts, very important. Salts which are formed by the partial replacement of hydrogen atoms of acids. From which? From the acids like the sulfuric acid, like the carbonic acids. Okay, so the partial replacement, when the partial replacement of the hydrogen will takes place, okay, acids, at that time acids are called acidic salts. Okay, so at that time which kind of the salts will form? These will be the acidic salts. For example, let's see, that is the ammonium sulfate. Okay, sorry, sodium sulfate, sodium bisulfate. Okay, is formed when the partial replacement of the hydrogen atoms by the sodium atoms of the base. At the time sodium bisulfate will form. So here you can see, from the sulfuric acid only one hydrogen has been replaced, only one hydrogen has been replaced by the metal. Okay, and another hydrogen is exiting as it is. Okay, so that is the reason behind it. Here when you will be dissolve this salt inside the water, at that time you will be get Na positive, H positive and sulfate 2 negative. Means this H positive, due to this H positive, this will be the acidic salt, because when H positive will form, this will be the acid. Okay, and when OH negative will form, that will be the basic, which we have already discussed. So similarly, when you will be dissolve this salt NaHSO4 inside the water, so what will be the product? Let's see. Na positive first product, second SO4 2 negative, and third one will be the H3O positive. So due to this formation, means the hydronium ion formation is indicating that this salt is a acidic salt and this species is existing inside it. So this is responsible. Similarly, if you have to form the NaOH will interact with H2CO3. So what will be product? Let's see. NaHCO3 plus H2O. Okay, so this is the sodium bicarbonate. Okay, and when you will be dissolve this sodium bicarbonate inside the water, this H positive will convert into hydronium ion. Okay, and carbonate 2 negative and Na positive, means this species is responsible to show the acidic behavior of this salt. Now next, basic salts. Salts which are formed by the partial replacement of hydroxyl groups are called the basic salts, similar as like the acidic salts. Example, calcium hydroxyl chloride is formed by the partial replacement of hydroxide group from the calcium hydroxide by chloride ions of the acid. So here you can see the example. We have reacting calcium hydroxide with the HCl, and here only partial hydroxide ion has been replaced from the calcium hydroxide and it will convert into CHOHCl. Okay, and H2O will form. In general, these salts formed when the reacted acid is not sufficient for the neutralization of the base. At that time it will be happen. Okay, so how it will be the basic salt? Let's see. When you will be dissolve this salt inside the water, so what will be product? Let's see what will be happen with this salt. Calcium 2 positive plus OH negative and Cl negative, means two different anions will form and the cation will be the same. Okay, so this is the reason behind it. We are saying this is the basic salt, because when you will be dissolve this salt inside the water, you will be get OH negative ion, and when OH negative ion is forming, means this will be the basic salt according to Arrhenius. Now next topic, that is the double salt. Salts that are formed by the mixing of two simple salts which are obtained crystallization. So here you can see there is a two examples, that is the potash alum, that is the potassium sulfate, aluminum sulfate, and 24H2O. It is also known as potassium sulfate, aluminum sulfate, and the 24H2O. Similarly, dolomite, calcium carbonate, and magnesium carbonate, both are the examples of the double salts. Okay, that is the potassium and the dolomite. So I hope students you must have enjoyed this video.